Now, next, let's move towards the point. Next topic is topic. Yeah, it is topic. A speed. A speed. We will see first of all concept regarding this topic. Then we will take some question based on this topic, this concept, so that we can get more clarity and we can practice it. Okay, we can do it as a practice. So let's define first of all this word. First of all, it will tell you a speed. Work of a speed is to tell us a speed with how much a speed your vehicle is moving. If you are taking two or more things, and those things are moving with some velocity or with some speed, then you can find which one object is moving more faster. But it will happen when you are taking two or more things. Okay, if you are taking only one thing, then only you can find yeah, with this much speed your vehicle is moving, your vehicle is running. Okay, so change of a distance, simple definition of speed is a change of distance, change of a distance with respect to time. WRT is the short form of with respect to time. Not try to understand. It is saying if there is a constant speed, for example, one kilometer, 1 kilometer, again 1 kilometer, there is no change. But it say if there is a speed, it means there is a change in a distance. Then a speed you will be able to analyze. Okay, you will be able to observe. So change of a distance with respect to time. After 1 second, what is the distance? After 2 seconds, if distance is changing, it means a speed is increasing. A speed may be decreasing. Okay, maybe decreasing. But remember, a speed is also, this is considered as a positive, not a negative. Unit will be meter per second. Simple. And then remember, this is a scalar quantity. Don't forget it. Okay, a scalar quantity. When it comes to a scalar quantity, we are already familiar with this word. It explains that quantity which is not providing direction. Yes, a speed will not be providing direction. Now next thing, a speed cannot be a speed cannot be negative. Remember, this is a truth, brother. It will be positive. It might be zero. Okay, it might be zero. But yeah, when it comes to velocity is velocity can be negative, can be positive, can be zero. But for a speed, this is not going to be negative. Formula for calculating speed is speed is equal to distance upon time. Simple. This is a famous formula from our childhood. Distance upon time is equal to a speed. From this formula, you can find the distance. Distance is equal to a speed multiple time. A speed multiple time. Right now, our focus is on a speed. On a speed. Now, next thing. There are 4 types of a speed. How much? 4 types of a speed. 4 types of a speed. Instantaneous speed, average speed, more, uniform speed, non-uniform speed. So one by one, let's explain. First, we are starting from instantaneous speed. Instantaneous speed. Again, it is not difficult to understand it at all. Instantaneous means current. Meaning of this instantaneous means current. Current means right now. Okay. What is the speed of your vehicle right now? This is what is the meaning of instantaneous speed. Clear. So instantaneous speed means right now. What is with how much your vehicle is moving at a particular time. We take a speed. For example, at t is equal to 4 second, what was a speed of your vacuum? Yeah, that is how we define instantaneous speed. Now next is yeah, we have a formula for this instantaneous speed, which is v instantaneous is equal to ds upon dt. ds upon dt. This v instantaneous velocity is equal to ds upon dt. ds upon dt. But remember, this will not provide a direction, not at all. That's why we took velocity. Okay. We will not use this all the times. Now next we have uniform motion, uniform speed. Any one of you can explain it? This word uniform. Remember, meaning of uniform is equal. It is saying that in equal interval time, if that object is coming same distance, equal distance, then we can say motion of the object is a uniform speed. That object is moving with a uniform speed. Okay. If those objects are covering equal distance in equal interval time, that's understand. For example, 1 hour, 1 hour, yeah, 1 hour, 1 hour, 1 hour, 1 hour, and the distance object is covering. This object is covering how much? Let's say 5 kilometer distance, then 5 kilometer distance, 5 kilometer distance, 5 kilometer distance. What are you understand? In one hour, again this is covering 5 kilometer. Again in 1 hour, 5 kilometer. This 1 hour is our equal interval time, and distance is the same. This will be known as uniform speed. When it comes to non-uniform speed, opposite of it, non-uniform speed. Just definition of this would be just opposite of it. Anything, if a interval time is changing or equal distance is changing, we will define that kind of a speed as a non-uniform speed. For example, time is the same. This 1 hour is the same. But what is happening? In one hour he covered 5 kilometers, but in another one he covered 6 kilometers, then 5, then 15. This is what is happening. Here we can see distance is changing. So that's why this type of speed will be known as our. Here we are understanding that in this case he covered more distance. Then here he covered less, 1 kilometer less, then 10 kilometer more. Decreasing, increasing. Yes. Distance is overall distance is changing. It is happening because of speed is increasing, decreasing. That's all. This type of speed we will consider it as a non-uniform speed. Yeah. Time can be changing. Sometimes time will be changing, but distance will be same. Distance will be same. If this is happening, again we will consider that speed as a non-uniform speed. Okay. These two things are crystal clear. Now let's take average speed. Average means total speed. Average means total speed. Average speed. So formula will be total distance upon total time. Remember, when it comes to average is total. So if it is the same total, so we will take distance total time, then divide the total distance upon total time, we will get average speed. What was average speed during the whole time? during from t is equal to 0 till the t is equal to 10 second. What was the average speed when object started from here to till here? Okay, and distance was how much? Distance was 100 meter. In that case, with how much average speed he covered this much distance from t is equal to 0 till t is equal to 10 seconds. That is what question will be asking when it comes to average speed. Notice, remember, distance will not be decreasing. Distance does not decrease. Yeah, velocity will be decreasing. Okay. So distance, speed. Distance, as we saw over here, distance will not be equal to negative. So distance never decrease, but average speed can decrease. So this was a note. Now let's see all these concepts based all these concepts on numericals. Let's apply. Let's apply all these questions. First case number 1 is if particle travels S1 S2 like this till the Sn. Distance in time t1 t2 tn respectively. What is happening? What is happening over? This is just an average speed. He's saying in case 1, if a particle travels S1, S is a displacement, S is a distance, this is a distance, S2 and then Sn distance, this much distance, means the distance is changing. You see distance is changing over here in time t1 t2 till the tn. T is also changing. Okay, nothing is equal, neither distance nor time. If nothing is equal, then our average speed will be S1 plus S2 like that till the Sn upon total time t1 plus t2 till the tn. Okay, this is what will happen. Here what are we doing? We are adding all the distance, and in denominator we are adding all the time. This is what is the meaning of average speed. This symbol is used for average velocity. We are considering this speed as a velocity. Now case 2. In this work, nothing was equal. Okay, remember. Our next case is if a particle travels S1 S2 till the Sn with speeds with the speeds v1 v2 va respectively. What is happening over here? Distance is given, a speed is given, but time is not given. This is what is present in this second case. Distance is given, velocity is given, which is the speed, but time is not given. We now to calculate time will be what? Something upon something, distance upon time. So distance upon time, distance upon a speed, distance upon a speed. This will be formula to calculate the time, where distance is given, time a speed is given. A speed is given. So for this case, average velocity will be equal to distance will be as it s1 plus s2 till the sn. But when it comes to time, distance is what? s1. Distance is s1, and the speed is v1, v2, v3. Okay, then s2 upon v2 till the sn upon v. This is what will happen. Here what is happening? Distance is given, velocity is given, but time was not given. So we just calculated time with the formula of speed, and equation became this equation. Okay, this was the second case. What is happening? What's the difference between these two cases? In this case, in the first case, distance was given and time was given, but in the second case, time is not given. Okay. Third case is if a particle travels with a speed v1, v2 plus till the vn in time interval t1, t2 till the tn respectively. Here, if a particle travels a speed this much speed in time interval, but distance is not given. To calculate the distance, we know what will happen. A speed multiple time. So average velocity will become distance upon time. So distance is nothing but v1 multiple t1 plus v2 multiple t2 till the vn multiple tn. Okay, this is our complete distance. But what about the time? Time is t1 plus t2 plus t3 till the tn. Okay, that is how you will calculate. This was hidden, this was also hidden, and we brought it logically. Clear? Logically. Yeah, there are questions based on this case. Again, they want to, even my mind want to emphasize on this more. In first cases, distance was given and time was given. Just we found average velocity which was equal to distance upon time. This was easy. But when it comes to second case, then in this case t was not given. Just we used this formula to to bring t. This is the distance and this is the time, which is equal to S1 upon V1. Okay. Okay. And in this case, distance was not given, and just we brought this thing with the help of this formula, basic formula of a speed. Then it became V1 multiple T1 plus V2. One thing you can notice, everything is changing. Even as speed is changing, time is changing, and the distance is changing. It doesn't matter. Matter is t and distance. In some cases, this thing will not be provided, this thing will not be provided. So we will bring all this. Now let's take a question. Now let's take a question. Now let's take a question. Question यार. Yeah, it's a complication, Bhante. Understand it. After ready. A person who moves first half, this half of his motion with a speed v1, with this much speed, in this half time he moved, okay, and remaining half, this remaining half, can you say that this is a complete t? Yeah, you can say. This is a part of this t. This is also part of this t. T upon 2 plus t upon 2 will become our t. Okay? Will become our t. and remaining half, it's talking about this remaining half with a speed v2, means here v1 is a something else and here v2 is a something else, but time is the same, time is the same. Then we found out average speed. First of all, which type of a speed is it? You would say non-uniform speed. Okay. Question is asking average speed. Question is asking average speed. This average speed. Okay. But time is given. Okay. A speed is also given. But distance is not given. So how to calculate distance? Now distance is considered as a speed multiple t. A speed multiple t. So average speed will become distance is s multiple t. So s will be v1 multiple t is t upon 2. T upon 2. Are we adding? No, not adding. Then next we have v1, not v1 but v2. T upon 2. Then upon time. Time is how much? T upon 2 plus t upon 2. So finally can you write v1 t upon 2 plus v2 t upon t 2 upon this will become your 2 t plus t again. Just we are simplifying this fraction. This is fraction v1 t plus v2 t in denominator this will become 20 upon this 2 will start to 0. Here t is a common v1 plus v2 upon 2t. T is again it is cutting this will be. Finally we got v1 plus v2 upon 2. v1 plus v2 upon 2. This is our average speed. What average speed? Nothing we did. Just we simplified from here, from this speed. And here we just substituted value of distance and value of time. This is the value of distance and this is the value of time. Okay, that's it. This is the main thing. When you will have velocity, just to substitute value over here, value of velocity, then you will get what this much. What is happening over here? Velocity, we are adding velocity and upon time, then it is becoming average velocity. Average velocity means it is not depend on distance and time. Yeah, it is not depend on distance and time at all. Not. Then you can use this formula. If equation is providing only velocity, not a distance, not a time, then we can use this formula. But remember, time should be equal and the speed should be different. Then we are able to use this formula, this equation. Okay, for n equal interval time. This is for note, brother, note. Note is for n equal interval time. Okay, time interval. Remember, for n equal means time is the same. Time is not same. Then here we can see it is nothing but arithmetic. Where v1 plus v2 it is going to the va upon 2. Okay, upon 2. v1, v2, v3 as the time is the same. Now second question. Let's take second question. Question number 12. 12. Question number 12. A particle is covering a particle covers first half distance of its motion with a speed v1 and remaining half distance with a speed. Find out average speed. Find out average speed. No problem. There is no problem in this question. We just read first question, then try to understand what things are we getting from this question. A particle which is covering first half distance. Let's say this is a half, which is a v upon 2. Okay. V is a speed. Half distance. V is a speed, but this is talking about distance. So s upon 2. Their distance is s. We consider it as a displacement, but right now we are considering this s as a distance. This is a half distance of its motion with a speed v1. With this much speed, he covered s by 2 distance, and remaining half, same half again, distance with a speed 2. The speed is something else, but time is the same. Again you can see a to b. Can you say that from here to till here total speed is s? This is our total distance. Okay, total distance. S is equal to s upon 2 plus s upon 2. He is asking average speed. What average speed? Again, we know average speed is equal to distance upon time. But what things are given by the question? First of all, distance is given s upon like this. Then a speed is given. But time is not given. Yeah. For time, we know that distance upon a speed. A speed is equal to distance upon time. So time will be equal to distance upon. Distance is s upon 2 plus s upon 2. Clear? Now, time is nothing but s upon 2 plus s upon 2 upon a speed. A speed is a v1 plus v2. This thing we got. This thing. Can you write this as a 2 s plus s? Yeah. Again, s plus s upon 2 upon v1 plus v2. It can be simplified further. 2s upon 2 multiple v1 plus v2 upon 2s upon 2, 2s upon 2. This will cut to each other. Finally we got v1 plus v2. It will be continue till the vn. It will be continue till the vn. Something is wrong here. 2s upon 2. Total distance is s. Yeah, total distance is s. This will be our again. Over here, s is a total distance, and the time is s upon v1 plus s upon v2. S upon v2. Yeah. Okay. S upon v1 plus v2 is equal to v1 s1 v1 s plus but this will be v2, then v1 s v1 plus v2 upon s is common, v1 plus v2. This is what is happening over here. D is s upon and the speed is v1. Speed is v1. v1. But this complete. So this will be our 2v1. 2v1. Total distance upon total time. Total speed 2v1 plus 2. Then we will get 2v1 v2 upon v1 plus v2. v1 plus v2. Okay. This thing will come. Here we were doing wrong over here. Just we take this complete and this half, which is invalid for time. If we are taking this complete, then this we will take complete. Okay, complete 2v1. When we will simplify, then what will happen? This multiply this, and then this will be multiplied by this. S will be common. S will cut to each other, and we will left over here v1. Okay, let's simplify this. S upon 2v1 into 2v2 upon 2v2 s plus 2v1 s. So s, then 2s is a common, v2 plus v1, and here 2 is a common, v1 into v2. This s will cut to each other, and we will left 2 twos of 4. This will become 2 twos of 4. 4. Something like this. Right now I am ignoring this calculation. Now let's move on velocity. Velocity. Whatever we saw definition of alphabet is also for velocity. Something is little bit different. Little bit difference is it has a direction. For a speed, a speed does not provide direction. Work of a velocity is to tell a speed with a direction. Change of displacement with respect to time. Main point is change of displacement with respect to time. Okay. And for a speed, change of a distance with respect to time. This is what we saw. Now unit will be same, meter per second. Meter per second. But when it comes to quantity, which quantity is it? You would say vector. Reason is it provides a direction. Okay. Next thing is vector can be, if this is vector, we would say velocity can be positive, negative, or zero. Clear? Or zero. It can be negative, positive, zero. So formula will become nothing but velocity will become equal to displacement upon time. Clear? But when it comes to total velocity, that total displacement we will take and total time. So here we have seen definition of a velocity with unit. Okay, with unit. As well as we have seen velocity formula. Now let's see types of velocity. First, we will start with instantaneous velocity, and it is written like this: v arrow and instant like this. Instant. Clear? Arrow is representing its vector. So meaning of instantaneous velocity is what? Velocity at a particular time. And for second, what is the velocity of an object? Okay, current velocity, instant velocity. So formula is for instant will be ds upon dt. Remember, time is not a vector quantity. No. Here s, we are representing displacement as a s. Remember, s is for displacement. So instantaneous velocity will become ds upon dt. where s is a displacement, where s is a displacement. But when it comes to only magnitude, then we use a mode, and this work of a mode is to remove arrow. This will become ds upon dt. ds upon dt means b will be equal to v instantaneous will be equal to ds upon dt. Work of mode is to remove the arrow. That's it. Note one thing, brother. Direction of this instantaneous will be always direction of instantaneous velocity will be always tangential. Okay, tangential to the path flowed by particle. For example, in this Cartesian plan, there is a particle over here. So it is covering this x-axis, and this is covering this y-axis. So tangential will be, this is like that. It is going like that. Okay, upward. He is going also horizontally as well as vertically. Now over here, at this point, what is the location of a particle? At this secant, we would say first of all we will draw a tangential. This will be direction of a velocity. Okay, this will be direction of a velocity. Clear? Which is the perpendicular to horizontal. Now let's take question. One question based on this. So question is if a displacement is given I cap plus 1 meter and t in secant, find a speed and velocity after 1 second. Try to understand this statement. What is it asking? Look at our question is, if a displacement is given in this equation, meters and it is in second, find the speed and velocity after 1 second. So answer will be our this instantaneous velocity will be ins t. Instantaneous velocity will be our ds upon dt. So minus t raised to power 2 minus t plus 1 upon dt. Can you write this as d minus t square plus t plus 1? Yeah, you can write. So depreciation of this t square will be minus 2t plus 1. Okay, this came is equal to, which is instantaneous velocity. Now after 1 second, what is the velocity after 1 second? He is asking after 1 second what is the velocity. So here you would say at t at t uh, at t is equal to 1 second. Okay, at t is equal to 1 second. Here velocity will become -2 multiple 1 plus 1. So velocity came as a -2 plus 1 means 1 minus 1 no, minus 1 means it is a decreasing -1 minus then minus minus plus and this became minus. Okay, let's say this is minus, then what will happen? -3 I cap -3 I cap -3 I cap. So mode of this instantaneous velocity will become just 3 I cap. Just we will remove minus. Mode will provide always positive value, and direction will not exist over here. It is providing only magnitude. Okay, only magnitude without having negative 3 meter per second. Okay, 3 meter per second. Now let's move towards the types of velocity. Towards the types of velocity. Next we have types of velocity, which is uniform velocity. Uniform velocity. Uniform velocity. So remember magnitude plus the direction. Magnitude plus direction both should be same. Both should be same. Means direction velocity, it is the same if this is a 5 meter per second, then again over here this should be 5 meter. Let's just say object, a vehicle is moving, so 5 meter per second over here, again 5 meter per second over here again 5 meter per second, which is a velocity. And he is also saying that direction should be same. If it is going in a straight direction, so it should be straight. Okay, that is what it is telling us. Remember, so everything should be same when it comes to uniform. Uniform is equal, everything equal. When it comes to non-uniform, so either magnitude or direction will be unequal. Okay, unequal. Non-uniform velocity. If either magnitude or direction of a velocity both change, if either Just understand, if magnitude is changing, and direction is not changing, we can consider that velocity as a non-uniform velocity. For example, this here his velocity was 6, over here 15. This happened. What I don't understand, velocity is changing. If this is happening, but direction is same, no matter. This will be considered as a non-uniform motion because of magnitude is changing. If a direction is changing, magnitude is not changing. Okay, direction is changing, but magnitude is not changing. Again, we will consider that type of velocity as a non-uniform velocity. Okay. Only one thing of magnitude and direction should be changed. That's it. We have an example. For example, this circle. Over here, velocity was v4. Over here v1. Over here v2, and over here v3. What are you understanding by this figure? You are understanding that velocity is a decrease, velocity is a changing, magnitude is changing, magnitude of velocity is changing, but direction is also changing. Both things are changing, magnitude as well. So this is an example of non-uniform velocity. Okay. You can also say that there is a circle, exact circle, velocity is the same, but anyhow its direction will change anyhow. When it comes to circle, velocity is the same. With the same velocity, a object is moving at the border of the circle. Now can we consider it as a uniform velocity? No, not at all. Why? Reason is one thing is changing, which is the direction. Direction is changing. Okay, direction is not constant. Only magnitude is constant. It is an example of a non-uniform velocity. Okay. So over here you can say V is equal to again V, okay, but direction is not. You have understood that. Now let's move towards his average velocity. Again, we know total distance upon total time. This is formula to calculate average velocity. We are familiar with when we were discussing about the average speed. There is a main point. This total distance can be written as delta S upon delta T. Delta means total, okay? Delta means total. Now there is a note which is where unique direction plus straight line is given in a direction is, this is a circle direction. We will consider it as a unit direction. Rectangular direction, straight direction, plus straight line, plus a straight line. In that case, our velocity will become it will be equal to a speed. It will be equal to a speed. Why? Reason is first of all we applied here mode. It means we removed what? We removed the direction. We removed direction completely. And second thing is that when we use mode, then our this thing will provide only magnitude. That's why this will be equal to a speed. Okay, a speed. And over here it is just line, which is a hint of a magnitude. Where because distance is equal to displacement. Displacement having a magnitude, not having direction. Clear? Not having a direction. Now let's take